Welcome back, guys. So we are starting up with a new chapter, which is polynomials. Okay. So in the 8th standard, we had seen about algebraic expressions. Okay. So any expression of the form x plus a is called an algebraic expression. Okay. We had also seen certain identities such as x plus y the whole square equal to x squared plus 2xy plus y squared. X minus y the whole squared is equal to x squared minus 2xy plus y squared. X squared minus y squared equal to x plus y into x minus y. So the general terminology that we use for an algebraic expression is called a polynomial. Okay, so in a typical algebraic expression of the form x squared plus x plus a, the the parts x squared comma x comma a are called terms of the algebraic expressions. Okay, so an algebraic expression can have any number of terms, right? It can have any number of terms, but it doesn't mean that it can have infinite number of terms. It has to have a finite number of terms. Okay, so any algebraic expression has to terminate at some point in time. So in general, if you take an algebraic expression of the form an x to the power n plus an minus 1 x to the power n minus 1 plus etc plus a0, where at least one of the constants an minus 1 etc are not equal to 0, right? Then it is called a polynomial. So poly meaning many. So an algebraic expression having many terms, one or more terms, is called a polynomial. When you have only one term in an algebraic expression, then it is called a monomial. Mono meaning one. When there are two terms, we call that algebraic expression as a binomial. When we have three terms in an algebraic expression, we call that particular algebraic expression as a trinomial. So in general, an algebraic expression with one or more terms is called a polynomial. Alright. And another aspect of a polynomial is that the variable, the exponents of the variable, right, has to be an integer, and it should be greater than 0. For example, if you have an algebraic expression of the form a1 x to the power 1 by 2, and if someone asks you if it is a polynomial or a monomial, the answer is no. Okay, so the exponent, right, of the variable in a polynomial has to be greater than or equal to 0, right, and it has to be an integer. The constants, right, are also polynomial, right? Constants such as 5, 6, etc. They are also they are polynomial. These are all monomials. Okay. See, what is the difference between a constant and a variable? Let us try understanding the difference between the constant and the variable. Okay. Let us assume the area of a square, right? What is area of a square? What is the formula? If the side's length is x centimeter, okay, then area of a square equal to the length of the side into length of the side, which is x into x equal to x square centimeter square. All right. So if you look at this particular formula, area is equal to x squared centimeter square. The value of the area changes as you give different values for x. For example, at x is equal to 1, the area of the square will become 1. At x is equal to 2, when the value of x is equal to 2, then area of square becomes 2 square, which is 4. When the value of x becomes 5, then the area of the square becomes 25. So you see that the area of a square changes and x assumes different values. Okay, so x can assume any value, right, depending on the circumstances or depending on what we supply to x. Hence x is called a variable. So the terminology variable means it is varying. Consider another scenario. The length of a particular square is 2x centimeter. Okay, where x can assume any value. Again, x is a variable. So length of a square is 2x centimeter. Now, what is the area of such squares? It is 2x into 2x, which is 4x squared. Okay. Now, irrespective of the value of x can assume any value and the area changes, but the number 4 in 4x squared remains a constant. It doesn't change with the value of x. So such numbers that do not change, right? When different values of x is supplied, they are called constants. So these are all typically numbers in the real number line. Okay. So this is the difference between constant and variable. Variable assumes different values depending on the scenarios. On the other hand, constants do not change, they stay the same. Okay. So now in a term, as I said, in a polynomial can have different terms, right? So the non-zero numerical value associated with variable in each of the term is called coefficients. Okay. So the non-zero numerical value attached to the variable, okay, in each term of a polynomial is called coefficient of that term. Alright. The power, right, of the variable, they are called exponents, right? So if you have a polynomial x to the power 5 plus 3x to the power 4, right, plus x cube plus 5, let us say this is a polynomial. Each of the term, in each of the term, the variable has got a certain power. Okay. The largest exponent, if you consider all the exponents, right, in each of the term of a polynomial, right, all the exponents of the variable in each of the term of a polynomial, if you consider, the largest exponent is called degree of the polynomial. The largest exponent of the variable, right, in each of the terms is called degree of the polynomial. So we can define degree of the polynomial only for polynomials with one variable. Okay. If there are two variables, so what do you mean with polynomial with one variable? If the variable is x, you will have only x in the polynomial. You will not have another variable. You will not have a second variable. If there are two variables, x and y, then the degree of the polynomial's definition changes. Only for a polynomial with one variable, the degree of the polynomial is defined as the largest exponent. You take each and every term, you take the exponent of the variable, the largest of those exponents is called the degree of the polynomial. So in the case of x cube plus x, the degree of the polynomial is 3. In the case of x squared plus 5, the degree of the polynomial is 2. In the case of x to the power 10 plus x to the power 7 plus x to the power 5 plus 10, in this polynomial, the degree of the polynomial is 10. The largest exponent is 10. Okay. So the degree of the polynomial is defined as the largest of the exponents of the variable in each of the terms available in the polynomial. Okay. Now, if there is a value x, right, at which, right, the polynomial evolves into a value 0, right, which means, let us say, if we substitute a particular value for x or y, whichever be the variable in that polynomial, we are talking about polynomial with only one variable, right? Let us assume that the polynomial is x to the power 5 plus 2. Then if there is a value of x at which x to the power 5 plus 2 equal to 0, which means when you substitute the value for x, right, and then when you simplify, the result is 0, then that number, that value of x is called 0 of the polynomial. Okay. So the polynomials are generally represented, right? Polynomials are generally represented as P of x. P simple bracket x. It denotes, right? P is a denotion for polynomial, and when you say of x, it is of variable x. That's what it means. So if there is a polynomial whose variable is t, we will write P of t. So you can use any letter. It is not that you have to use only P. You can use G of t. That is also a representation of polynomial. That is only how we give names for variables, okay, in calculation. Similarly, you know, the polynomials can be given a name, right? G of x, S of x, or R of x, right? Z of x. These are all representation of polynomials so that we can easily refer to a polynomial in mathematical calculation. Okay, so it is usually written as a letter. It could be Z open bracket x. Then it means, you know, we are talking about a polynomial whose variable is x. Okay, so let us assume if P of x, right, if P of x equal to some polynomial, if there is a value for x at which P of that value, let us say that value is a, okay, a which is a real number. So there exists a real number a in the real number line for which P of a equal to 0. Okay, so what do you mean by P of a? You substitute the value a for x in the polynomial, and if you are getting a result as 0, then that particular value a is called 0 of the polynomial. Okay, so if there exists a real number a for which P of a equal to 0, then a is called the 0 of the polynomial or root of the polynomial. Okay, we will meet again in our next video. We will continue with the discussions on polynomial. If you have any doubt, you can email to us. You know, I keep repeating in my videos that the email ID to which you should send email in case if you have any doubt is askmentorguru@gmail.com. ASKMENTOR guru GURU@gmail.com. And whenever you listen to the video, I strongly recommend that you have a paper and a pen, and as I keep giving you example, you write it down so that you better understand, you know, what we are teaching. The second thing is, you know, whatever we are discussing through the videos, these are all directly from NCERT syllabus only. Okay, so if you download the NCERT book, or if you have a printed version of the NCERT book, right, refer to the NCERT book and, you know, relate back to the video. You will be able to easily follow up with the video. Okay, so you will be able to follow the video and you will be able to understand the concepts that I am describing here. Right, so these two things are very, very essential. One, you must have the book of NCERT downloaded, or you should have a copy of the book. Second thing is you should have a paper and a pen, and then you have to listen to the video, right? Write down the notes along with the video. Also refer back to the NCERT book. You will be able to understand whatever is told in the NCERT book. You will find examples, right? You will easily able to correlate, right? So that is how you should be learning these lessons. Okay, so we will meet again in our next video. Until then, signing off. This is TK Sridhar, an alumni of IIT Mumbai. If you like this video, you subscribe and you press the bell button, and you please share it with all your friends. Okay, please wait for my next video. Thank you.